Hey, Dr. Mike here. Methylation is a natural process essential for life. Stay tuned to learn what it is and what nutrients can help.
You're listening to Live Foreverish, a show dedicated to helping you live just a little longer. Here's your hosts, Dr. Mike and Dr. Crystal Gossard.
All right, welcome to Live Foreverish. Dr. Crystal, are we really going to try to tackle methylation today?
I think we can.
I think we've done a pretty good job here. We got some good information.
We have. I mean, there's a lot of conversation around methylation. This prompted me to take a look at some of my 23andMe reports to figure out my methylation status.
Well,
we can talk about that.
Let's just make it real simple first.
Mm-hmm.
Why are we interested in methylation? Like, give me your don't look at your notes. Just like.
No, I'm just thinking it's something that occurs in our body that is as important as breathing. You know, it's important as, like, I always think about how our nutrients are broken down. Glucose is broken down in the body, or the citric acid cycle, and these processes or these things in the body that just happen.
Yeah, and if they don't.
And then if they don't, it's essential to life.
Yeah.
And if there are problems with your ability to methylate, then it's related to a host of health concerns
issues and problems
that people may not necessarily link to methylation, but simple tweaks can improve it.
It's occurring inside your cell, so it's not like blood pressure or something that you can like focus on and check. And that, although we can check all this, but you know what I mean. I think when these, like you mentioned, these processes that are going on that are so essential, we don't relate to it. We relate to things outside of it. Blood pressure and
we relate to the
cholesterol
manifestation of these problems, but this is kind of getting to the core and getting to the root, because elevated blood pressure could be a result of poor methylation. So when you're looking at disease prevention versus, healthcare versus sick care, then these are conversations that come up.
Yeah, so it's a natural process. It's essential. It helps regulate everything from your metabolism and brain chemistry to your immune function, even affects DNA expression, right? And in a way that is called epigenetics, or an epigenetic mechanism, which simply means methylation has a way of helping your genes turn on and off. It doesn't change the DNA; it's doing it above the gene, which is what epigenetic means. It's influencing how a gene can turn on and off. So it plays a huge role in a lot of different stuff. And we want to make sure that we are adequately methylating. How's that?
I think that's important.
That sounds pretty good. So tell us, what are some of the things? I know we brushed over it kind of quickly, but what are some of the things that have been connected to poor methylation, or maybe I should say low levels of methylation?
Well, I think that the key marker that occasionally, I put that in quotes if you can't see me, occasionally is measured if you have a really good doctor, is homocysteine. That's a blood test that some of the more integrative physicians will manage or will test. And that's a first sign, I think, that from an objective marker that maybe you're having trouble methylating, and it could be due to you're not taking in enough nutrients, methylating nutrients that support the methylation process, or maybe you have some type of genetic predisposition to not methylate quite as efficiently.
Right. So let's review that real quick. So in the methylation process, it starts with methionine, right? That's that amino acid, right? Yeah. And you need B vitamins, folic acid, that kind of stuff to allow methionine to convert correctly.
Right.
And if you're missing those B vitamins and stuff, the side reaction becomes homocysteine, right? It's like a little side thing off of what you normally would want to do.
Right. Yeah. So homocysteine is a byproduct of the methylation cycle. Yes. I think your main idea is that methionine is creating SAM, and that's the main methyl donor in the body. I mean and that's SAM is known is S-adenosylmethionine. And that is what's going around the body, performing all of these methylation reactions, donating these methyl groups. And so homocysteine is a byproduct of that SAMe doing its job.
Yeah.
And that SAMe kind of needs to be recycled, or that SAM needs to be recycled. And a part of that recycling process, that's where you have your B vitamins, but the methyl forms of the B vitamins are needed to then donate more methyl groups. So it's kind of like pass the basket.
Yeah.
We're passing these methyl groups, which is just a carbon, 1 carbon, 3 hydrogens. That's a methyl group. So we're just passing this little carbon hydrogen apple along the way.
And that needs to be efficient.
And it needs to keep moving. And sometimes, it gets clogged.
It gets clogged up. Yeah, and then that's when you can start to see a little bit of the homocysteine kind of elevate. Homocysteine is natural. It does perform some metabolic function. It's just when it starts getting too high, right? That's when we start questioning.
Yeah, it's when you get stuck. You get stuck at that homocysteine, and you don't have the proper form of folate that's needed to donate its methyl group to B12, which then kind of keeps everything going. So yes, you get clogged there. Homocysteine, it can also help to go down a different pathway to make glutathione. So it's not all bad.
It's not that way, but it does have a role here and there with some other processes.
Yes.
But generally speaking, too much of it means you're stuck. You're clogged. And you're not recycling those methyl groups the way you're supposed to.
Yes, and then that translates into increased cardiovascular risk, blood vessel damage. When too much homocysteine is around, then you start seeing increased risk for clotting. So homocysteine typically is known as a cardiovascular marker, which is likely why a doctor would be testing it to look at cardiovascular risk.
For sure.
But it's telling us more than that. There's telling us that, hey, maybe there's something going on with this methylation cycle, and it's worth exploring further.
Yeah, it's not just the heart. You got to go to think of it like moving upstream where the main issue is, right? So homocysteine is kind of a downstream byproduct of being a clogged methylation process. Has some roles, but can ultimately be harsh on your arteries. Homocysteine, and so you need to think, okay, but why is that homocysteine too high? You got to move up to the source, and the source is you got a clogged methylation process, and that's not good because this is a natural process essential for life.
Yes.
Matter of fact, if you got a clogged system, we already know it's associated with cognitive decline, mood related concerns, cardiovascular disease, as we said, and just aging. Right? Poor low levels of methylation increases. Make sure I'm saying this right. Increases your biological age.
Well, it depends. I don't know if methylation patterns can predict biological age. That's probably a better way to put it, which kind of, I know we wanted to talk about how to know if you have poor methylation, and there are a couple of ways to do so. We talked about the homocysteine, but yes, DNA methylation helps us look at how methylation impacts the way the genes express themselves, and those patterns influence how we age. It's kind of can tell us, depending on how methylated it is, if you are older or younger than your your actual age, your chronological age.
Which is the big movement now, right? A lot of different companies coming out with these biological age testing. It's really not. It's not my chronicle age. I'm I'm 53. But what's my age inside with all these processes going on, right? That's so a lot of people are very interested in kind of knowing that kind of information. So how are we going to know? How if I'm just average Joe out there, I'm listening to this podcast, all this, okay, methylation sounds pretty important. How do I know if it's something that I need to address?
Well, you have to first look at your symptoms and things that you can identify. One, do you have mood disorders? Are you having, because this cycle is controlling the production of neurotransmitters, dopamine, serotonin. It's involved with estrogen metabolism, helping the body to detox estrogen. So if you have, elevated estrogen or estrogen dominance and you're having kind of symptoms related to that, then you may want to think about the methylation. If you, of course, the homocysteine, if you test homocysteine, you'll know. But really it's so you can look at those symptoms and then you can also then look at the actual tests. There are genetic tests that you can take.
I like that idea of, just looking at symptoms first and seeing where you're at with that, because it's almost like let's just use depression as an example, right? And maybe you're being treated for it, or maybe you're going through some you're addressing the depression, but maybe you're not improving the way you think you should be, or your doctor thinks, now you're on that drug, you're going through. I wish you were at a better level. That's maybe okay. What's going on in me? And maybe that links back to a possible methylation issue.
Right. Yes. You. That's absolutely right. So it's kind of, you find people going on this journey, thinking about their methylation when they find themselves sick. Yeah. Or, and then they're trying to kind of figure out what's the root cause. So genetic methylation testing, you have kind of two different types of tests. So you have the test to look for SNPs, which are those single nucleotide polymorphisms, like variations.
Just little variations that happen
genes,
naturally.
Yes, that happen naturally.
They actually make me and you.
Exactly.
Right? Those
it makes us, and it makes our families, because a lot of these patterns are kind of passed down from father and mother to their offspring. And so there are a couple of genes related to methylation to check, and that's the MTHFR and the COMT. And so the MTHFR, that's the one that I was able to identify on my 23andMe. And this is the gene that codes for an enzyme that's needed to convert folic acid into your active folate or your methylfolate.
Right.
And that methylfolate, if we go back to the beginning, that's the folate that's needed
in that cycle,
in the methylation cycle. So some people aren't able to take the folate from their food that they're eating. You're eating a healthy, great diet, lots of green leafy vegetables. But if your body's not able to turn that into the active form, then you can have these problems.
Right.
More, and I would say efficiently.
Right.
And so,
and the only way to know that is you got to look at this SNP, if you will.
Right.
Yeah. You got tested for this one.
I did, yes. So it's a part of, like I mentioned, it's a part of my 23andMe. And I had just one piece of the variant. So my enzyme activity, again, that enzyme that converts folic acid into folate, is about 83% activity.
Right.
So it's not bad.
Not bad.
I mean, there are some people that's, in the 20%, 60%. But imagine your body is not able to make active folate. And you find that this is widely prevalent
In a lot of people, because
in the population.
That active form, that methylfolate, is part of the methylation cycle, but it has its own roles too in nerve health and it's you want vitamins, and for the most part, in most cases, need to be activated, right?
Yeah.
And if you can't activate them, it's like you're dealing with, I don't know, what is it, like some weak ones. I don't know what right. You're not full force with it,
Yes. Yeah. So that's one test for you, and of course you don't have to get it just through the 23andMe. There are a lot of places. Yeah, just cheek swab is not a blood test. They're just kind of getting your DNA
right
and analyzing it to see the variants that you may have at this particular.
And then there's COMT,
gene.
right?
Mm-hmm.
That's that codes for an enzyme that plays a role in neurotransmitter production, hormonal production. Pretty important, right? Pretty important down the line. But again, little variations in that might be the reason your hormone levels are too low, or you're not your steroid hormone production is not as robust as maybe it should be given your age, something like that, right?
Yeah, and well, the COMT is more it's more of the hormone metabolism. It's specifically estrogen metabolism, and it's involved with kind of the different estrogens being broken down, and ultimately you want them excreted, right?
Yeah. So that some people who have that SNP that maybe slows that down for them, right? And certain types then of estrogens can build up, and some of those types of estrogens that build up could be problematic. They could be more proliferative and can lead to some growth issues.
Yes.
Right. So those are two, and then of course we already mentioned you can just test homocysteine, right? You can now. Did you, knowing your MTHFR was about 80-something%? Did you then follow that up with homocysteine, or was that part of all that testing?
No. So I did not. I've had my homocysteine tested in the past, just because I run a lot of preventative tests. That's my thing. I have a doctor. I'm telling you, people look for a doctor that knows about
this stuff,
these preventative tests and has an interest in helping you to stay healthy. And so, I have a doctor. My labs, I'm like 10, 12 pages of labs that I receive. It's yearly. And so I don't have any problems with homocysteine, but I do make a point to eat lots of foods with folate. I try to limit folic acid. We know it's in lots of your grains, your cereals, it's fortified. And so I try to balance that out. And I also make sure I take active folate. And that was very important when I was pregnant as well.
Yeah. I think you're doing the right thing, because if you're at 83% of this gene, making a little less methylfolate, what you're doing is you're increasing the substrate, the stuff that you start with, that raw material, right? So you're offsetting that 83% by just running that cycle more, because you're eating all that good stuff.
Try to.
At the end of the day, you do a pretty good job. And then then we have to remember too, methylation is also involved in some DNA control, turning on and off. In most cases, turning off certain genes when they need to be off. That's different type of testing though than from the SNPs, correct?
That is, yes, and we kind of touched on this earlier, and it's helping us to see the variations in the patterns as to how these methyl groups, again, that carbon and the 3 hydrogens, how those methyl groups are locked in to different sites on our genes. And depending on that pattern, it can tell us how our age, environment, diet, lifestyle influence the human genome, and we can measure how methylated different genes are, and then impact. One thing that we didn't talk about when it comes to genetic methylation, it typically silences that gene, or silences the gene, or turns it off. And so you can now look at the different genes that are turned off and see how that impacts health.
Right. Yeah, I know there's a lot of research looking at, there's certain genes associated with too much growth, like cancer growth and whatever. And those genes, in some people, genetically speaking, just being more active and using methylation to help kind of control those.
Yeah.
Right, and decreasing that your risk for cancer. So what we're going to get into now is what can I do about all this, right?
Yeah.
So this is the testing of everything. But let's just we've covered a lot of information here, and I think I just want to review real quick. Methylation is a natural process essential for life. In the same way, being able to get energy out of your food, you got to have methylation, right? And so think of it that way. And so we want to do things that support it at the end of the day.
Yes.
Good review?
Good review. So how do you support it? Well, I think, one, we have a couple of questions that we can think about. One, do I need to get tested?
Right.
Is this something that's important? And that's an individual question.
Homocystine's easy, though. It's not like a big major thing. That's a simple blood. Yeah, ask your doctor to add homocysteine.
Yeah.
Just make it part of your 13-page report.
Right.
Yeah, so that one I think is easy. Now, whether you need the rest of that kind of testing, I mean, you kind of just have to look at your life, look at your risk factors, and
look at what you eat regularly.
How are you eating? And maybe so. That's just it's a personal kind of decision. But the homocysteine one's pretty easy.
Yep.
Okay. So let's talk then about what are we going to do if we have low or poor methylation. And I think the first thing you wanted to talk about was that SAMe again.
Yes,
right?
SAM, that S-adenosylmethionine.
Well, I call it SAMe. Am I the only one that calls it? You call it SAM. I call it SAMe. Because there's an E.
There is an E.
It's
you
cute.
see it
SAMe.
sometimes without the E. So again, that's your universal methyl donor. It's made from methionine. Again, that amino acid is very abundant in our diet.
Everywhere.
Yes, I think it's over half of the amount of amino
you
acids
don't
that
need
we
to
get
worry
in a
about
day.
You don't
You're
need to worry
getting
about it.
plenty of methionine. But again, that methionine may not be
It's
properly.
the cycle that's what's
it's
key.
the cycle. So many people can just add SAM or SAMe to their regimen.
And that helps.
And now you are giving your body directly the universul methyl donor. It is ready to donate.
It's ready to go.
Ready to
rock and roll. Very, very easy to take. Very simple nutrient. And listen, SAMe has good research behind it for mood issues.
Yes.
I think that even
Joint health.
It's joint health.
Yes.
Joint health and mood.
Joint, mood, liver.
See, look at all that.
Those are the three kind of big ones.
Yeah.
A lot of this methylation is happening in the liver.
Yeah. So there you go. That's the first one. Very simple nutrient all over the place. You can find it anywhere.
But you can't take SAMe and forget about those. I call them cofactors. You have to, because you'll clog up the system, because SAMe, along the way, you're just a couple of steps. It's homocysteine. Once it's donating, it's doing its job, donating the methyl group.
Goes to homocysteine.
And you have to detox.
Now you need those other methyl, right, to go into that cycle.
You need the B
again.
vitamins. So that's kind of number 2.
B vitamins.
Specifically B12, B6, folate, and even B2, riboflavin.
Yeah. Now, do you want to look for the methyl forms of these, the more active forms? Like, do you want methylfolate? Do you want methyl B12? Like those?
This is a great question. Generally speaking, yes. You want the methyl forms, but you have to make sure you get all the Bs, because if you're just taking, let's say, methyl B12, which a lot of people take, tons of methylcobalamin, and then you don't have the methylfolate, you have to have them all. They work in concert. So yeah, you need those. The riboflavin is needed for it's a cofactor for that enzyme, the MTHFR enzyme that converts folic acid into folate. So you need riboflavin, and these are,
which is B2,
vitamin B2. Yes.
Yeah, and so how can we just go with a nice, good, complete B complex product?
You could. But you have to check the labels.
Make sure you
see
got all
what
of them.
forms, and that's where you often see the focus on active B vitamins or activated B vitamins. That's important so that you don't have to try to rely on the body to do it.
Yeah.
You're just getting them directly.
Listen, and when you start, whether it's a B complex or you're doing the methylfolate, methyl B12, a lot, like my dad, when he was around, he started taking this. This was before he got sick, but he was like a new guy.
Oh.
He had so much more energy.
Yeah.
With the bees, his methylation obviously got better, but he just overall.
Yeah.
But
so
good.
And I kind of was cautious earlier when you said, can you just take the methyl forms? You can, but I want to be cautious because there are so many other cofactors. I mean, we're talking about this one kind of methylation cycle, but there is, you have the folate cycle, you have the COMT cycle, you have all of these cycles that's interconnected, and one impacts
the other.
The movement of another, and there are other, like zinc is involved. There's so many other cofactors or nutrients that's needed, your vitamins and your minerals that's needed to keep them all moving, and you don't want to just ramp up one of those cycles.
They all need to be working good together.
And then now you're clogging up another cycle and you're creating more problems in your life. So that's why you have to take a complete nutrient formula.
And don't forget, eat better. Let's go to food, right? Because the standard American diet is often not giving you all of these from zincs and the other minerals and the Bs, and it's heavy calorie and low nutrient value.
Right. So as I mentioned, folate, your green leafy vegetables, kale, collard, spinach, turnip greens, arugula.
I love all that.
Asparagus, Brussels sprouts, broccoli, and then your B vitamins are going to come from whole grain. Not white.
Whole grain. You got to make sure it says whole grain.
Not whole wheat.
No, whole grain.
Whole grain and whole grain dishes. You'll get some of those B vitamins.
I love arugula.
Me too. Peppery.
I like to add it. You can get a simple salad and just add some arugula, and it changes the whole thing.
Yeah.
It is so good. And so you got your Sammy. You got your B. Those are probably where to start. Yeah. Get the right food going. There's some other things that can help. Choline, right?
Choline is involved in the regulation of homocysteine concentration. We love eggs as a source of choline, specifically the egg yolk. And then TMG, trimethylglycine.
Yeah. This was the big one. So years and years ago when I started in the integrative field, whatever, TMG was the big guy for helping homocysteine, methylation. That was the one that was kind of the first, at least in my learning, that was like the first one that I was like introduced to.
Yeah. So trimethylglycine is made from choline, but some people, just kind of need a little bit more.
Beets, wheat, and spinach.
Oh, yes.
You could do a nice little like roasted beets on the spinach salad.
There you go. You're getting folate,
you're getting
B
bunch
vitamins.
Of stuff.
You're getting your betaine.
I love
or your
roasted
trimethylglycine.
Beets. I haven't had them. I'm gonna get me some roasted beets here soon.
Get some with some goat cheese and candied pecans.
My
and arugula.
Now you got me. I'm going down the food line. My Greek grandma, she would make one of the things I always forget to tell people about growing up half Greek. We believe it or not, most of what they ate were on the vegetable side. They didn't have a lot of money for me. And one of the things she would make was this big bowl of like white beans, like kidney bean, or maybe
cannelli?
navy bean. Is navy bean the white bean, the smaller one?
Cannelli beans.
Maybe something like that. Like it was white.
Uh-huh.
And she would have roasted beets in there. she'd have, I don't remember if it was like kale or spinach, and then on top of it was just a big thing of feta.
Ooh.
It was so good. Oh, was that your stomach?
No. That was me just thinking about feta cheese.
It's so good. And so there you go. We kind of talked about nutrients that are going to help, the foods that are going to help. Here's the good news. If you do, if homocysteine's high, if you do some of the SNPs and you got some of those variants that aren't working well for you, if you do the right food and do some of the right nutrients, you can correct this.
You can. I mean, the people, when they realize that they don't have to take their antidepressants.
Fix methylation.
Their mood disorders, anxiety, depression was related to methylation. I mean, it changes lives.
Yeah, it does.
You hear stories of women who've had multiple miscarriages, and they fix their methylation and they have a healthy baby. Those are the things that make you say, wow.
Again, a natural, essential process to life. And in the same way you got to make energy from food. I mean, think about it. It falls in that same category. And so methylation is something we need to think a little bit more. There is a test that we want to share with you. If you go to lifeextension.com/labs, that's the SNPs test we were talking about, right?
Yes. Yep. That's that links to we have over 400 or so. We have a lot of labs.
Yeah, Life Extension.
But there are a couple related specifically, 2 or 3 related specifically to methylation.
Yeah. And then there's also one called True Age Complete Epigenetic Age Profile Fingerstick Test. It's a long name. So we do. So Life Extension does offer some of that. You can, again, check it out at lifeextension.com/labs. And when you're there and you want to purchase, when you check out, put the code podcast, because you're going to get 10% off $50 or more with free shipping and handling, right?
Yeah.
And they do that because our sponsor, Life Extension, just wants to say thank you. And then you could go over to liveforeverish.com. We're going to get you all over the internet. At liveforeverish.com, there's well over 400 or so episodes that you can download, watch, share, comment, and subscribe so you would never miss a show. That's liveforeverish.com. I'm Dr. Mike.
Dr. Crystal.
Thanks for listening.